Namaste to all of you. Now today I will start the new chapter Binomial Theorem. Okay. Already I hope that for you conic sections completed. Now present we are doing vectors. Already they are recorded. So they are sending vectors. After vectors they will send you three-dimensional geometry. Now algebra part. Little bit pending part is there for us. So now within this month, today date you can follow the date 24th 08 2021. So now I will try to wind up the chapter binomial theorem. Okay, now today chapter name is binomial theorem. Okay, now while entering into binomial theorem, first of all we have to discuss about the binomial expansion. Okay, ma'am. So what is the meaning of the binomial expansion? In the name only its meaning is there. Binomial means, for example, x plus y whole square. What is the expansion for this one? X square plus 2xy plus y square. So in this expansion, if you observe, only two terms are there. Only two terms are there. Two variables here. X is one variable, y is another variable. So this is known as the binomial expansion. So binomial expansion means an expansion contains two variables. Simply we can say like that. Binomial theorem means regarding such a kind of expansions we will discuss in detail. Now today in this class basic formula I will tell you more. Maybe all of you know what is the formula for a plus b whole square. Means a plus b into a plus b means a square plus 2ab plus b square is the value. Next, if you observe, what is a plus b whole cube formula? A plus b whole cube equals to a cube plus 3a square b plus 3ab square plus b cube. This is the value. If you observe a plus b whole power 4, by multiplying, if you simplify, you will get the value a power 4 plus 4 a cube b plus 6 a square b square plus 4a b cube plus b power 4. Or these are the expansions, that two binomial expansions. But if you observe all these expansions, we have to identify some pattern is there. What is that pattern? Listen. Here first of all, a highest power we are writing. What is here? A plus b whole square. So a square. A plus b whole cube. A cube. A plus b whole power 4. A power 4. After this term, in each and every term, a power value reduced by 1. A power value reduced by 1 means here a square is there. Here a power 1 is there. Of course, here a power 0 is there. Similarly, in this expansion also, a plus b whole cube. A plus b whole cube means first we are starting with a cube. After a cube, a square. Next, a power 1, a power 0. Similarly, here also if you observe, a power 4. After that, a cube, a square, a power 1, a power 0. So, here if you observe, one pattern is there. From left to right you are moving. From left side to right side you are moving. Gradually, a powers are reduced by 1. So, here the first observation is starting with highest power and left to right reduced power by 1, reduced by 1, reduced by power 1. That is the first observation. Next, second observation. If you observe the second variable b, what is the powers of b? Cross check one time. In the first term, b power 0 is there. Next term, b power 1 is there. Next term, b square is there. So that means gradually b powers are increasing from left to right. Starting with b power 0, after that gradual increasing and goes to highest power. Same here also you can observe here. B power 0, b power 1, b square, b cube. Same here also. B power 0, b power 1, b square, b cube, b power 4. Means powers of b, otherwise here you can write powers of b gradually increasing by 1. So here if you observe, in each term to next term, gradually powers are increasing. That is the second observation. Next, third observation. In every term, what is the sum of the powers? Tell me here. For example, here a plus b whole square is there. So here the degree of this term is second degree. Since a square is there, here cross check a power 1, b power 1. So in this term also, the sum of the powers is equal to 2 is the value. Same here also, b square second degree. So that means in a plus b whole power n, of course n belongs to natural number, a plus b whole power n, in each term, sum of powers is n. Got it now? For example, if you observe here, power cube is there now. So a cube. Here a square, b power 1, 2 plus 1, 3. A power 1, b square, 2 plus 1, 3. B cube, 3. So even here also if you observe, here power 4 is there now. Power 4 is there. So in the first term, what is degree? 4. Second term, 3 plus 1, 4. 2 plus 2, 4. 1 plus 3, 4. Here 4 is there. That means this is the third observation. In each term in this binomial expansions, the sum of the powers is equal to n in the expansion a plus b whole power n. Got it now? So this is the next observation. Next, fourth observation. What is the fourth observation? If you observe here, a plus b whole square, power 2 is there here. How many terms are there? 3 terms are there. A plus b whole cube, power 3 is there. Here how many terms are there? 4 terms are there. Here power 4 is there. How many terms are there here? 5 terms are there. So by observing this point, we can say one particular point. In a plus b whole power n, number of terms equal to, how many terms? Number of terms is equal to n plus 1 is the value. Got it, ma? So in the expansion a plus b whole power n, the number of terms is given by n plus 1. So this is the fourth observation. Next, one more important point is there. Here if you observe, in a plus b whole square, here 1 is there indirectly, 1 into a square. Here 2 is there, 1 is there. So here if you observe 1, 2, 1, these are the coefficients. 1, 2, 1, these are the coefficients in the expansion a plus b whole square. Similarly, if you observe a plus b whole cube, if you observe a plus b whole cube, tell me what are the coefficients here? Here 1 is there, here 3, here 3, here 1 is there. So in the expansion a plus b whole cube, the coefficients are 1, 3, 3, 1. Next, similarly tell me a plus b whole power 4. What are the coefficients? Tell me. Coefficients are 1, 4, 6, 4, 1. These are the coefficients. Okay, na? So keep in our mind this point also. So these are the 5 observations which we observe when we are writing these binomial expansions. Once again, listen. First of all, binomial expansion. What is the meaning of binomial expansion? An expansion contains two variables is called binomial expansion. Already you know all these things. Now next point is a plus b whole square formula you know. A plus b whole cube also you know. A plus b whole power 4 also you know. Now here if you observe these binomial expansions, we can observe few important points. What are the few important points? Here a plus b whole square, first powers of a we will discuss. In each expansion, power of a starting with highest power gradually decreased by 1. That is the first point. Second point, b power 0 means powers of b starting with 0 gradually increases to highest power. That is the second observation point. Next, third observation point, in each term, for example, if the expansion is a plus b whole power n, in general, where n is the integral value, positive integral value, then in this expansion, each term, the sum of the powers is equals to n. That is the third observation. Next, regarding the number of terms in the expansion, a plus b whole power n, if n is a positive integral value, then the number of terms is given by n plus 1 is the value. And here, if you observe here, next one more important point, in a plus b whole square, 1, 2, 1, these are called coefficients. Of course, they are named as binomial coefficients. Next here, 1, 3, 3, 1, in a plus b whole cube, they are the binomial coefficients. Similarly, in a plus b whole power 4, 1, 4, 6, 4, 1, they are named as the binomial coefficients. So these are the observations. Next point, is there any method to find these binomial coefficients? Yes, exactly. One method is there. Let me write that one. I hope that all these points are clear for you. Next, listen here. So first of all, this is the add this 1 plus 1 2. First starting with a plus b whole square. If you observe, in a plus b whole square, what are the binomial coefficients? 1 2 1. So 1 to 1. These things you know already beginning. And the method of finding binomial coefficients in this method, this method is known as the Pascal triangle method. Pascal triangle method. So this is the one method to identify the binomial coefficients. Next one. Again you can add these two, 3, add these two, 3, just keep 1 1. These are the coefficients in, if the power value is 3, cross check one time. If the power is 3, what are the coefficients here? 1, 3, 3, 1, like this. Next, add these two, 4, add these two, 6, add these two, again 4 you will get, again keep 1, 1. So these are the binomial coefficients whenever the expansion is a plus b whole power 4. Okay. Next, similarly, tell me, if you take a plus b whole power 5, then what are the binomial coefficients will be? Tell me. Add these 5, add these 10, add these 10, add these 2, 5, keep 1, 1. That's it. So these are the binomial coefficients in the expansion of a plus b whole power 5. And this method of finding binomial coefficients is named as Pascal triangle method. Pascal triangle method. Now, basing on this one, directly you can write the formula also. Now tell me, what is a plus b whole power 5 expansion value? In a plus b whole power 5, these are the coefficients. That thing we know. Next, how the expansion will be? First, a highest power will start. A highest power. Here a plus b whole power 5 is there. Na? So a plus b whole power 5 means a highest power 5. Then 1 into a power 5 complete. Next quotient is 5. So 5, a power value reduced by 1, then b will come. Next binomial coefficients 10, a cube, b square will come. Next again tell me 10, a square, b cube will come. Gradually a power value reduced by 1, b power value increased by 1. Next value 5, a, b power 4. Last value b power 5 is the value. So with the help of this Pascal triangle method, we can identify binomial coefficients. After identifying the binomial coefficients, then directly what the observations we did, with the help of those observations, we can write the expansion like this. And here in this a plus b whole power 5, the binomial coefficients are 1, 5, 10, 10, 5, 1. So this is overall the introduction about the binomial expansion. Now it is okay. For example, if the power 10 is given, a plus b whole power 10 is given, then can we proceed in this manner, ma'am? It is a little bit lengthy. Na? For example, 20 is given. Instead of here 5, if they will give 20, a plus b whole power 20, then how you can do? How you can do? Can we do in this method? No, it will be a little bit lengthy. Then how you can proceed? How you can proceed? Okay, we will do. Next, further, we will do, that is the value. So, for that, exclusively these binomial coefficients, powers of AB, we know, highest power with A, it will start gradually decreased powers of A by 1, and B power is 0, it will start. Slowly it is increased by 1. That thing we know. Regarding these binomial coefficients, listen. While entering into that one, we introduce the factorial. Factorial. Okay, this is the new definition. Factorial. What is the meaning of the factorial? Factorial means, mom, if n is a positive integer, okay, n is a positive integer, or simply n greater than or equal to 0, you may take 0 also included. N factorial is given by n into n minus 1 factorial. Okay, ma. And here we can define 0 factorial is equals to 1. 0 factorial is equals to 1. Here n value in the factorial notation, ma, n greater than or equal to 0. So if n greater than or equal to 0 is a number, that to integer value, n greater than or equal to 0 is a integral value, then n factorial is defined by n into n minus 1 factorial. For example, if they will give 3 factorial, what is the 3 factorial means? 1 into 2 into 3, that's it. And here few students they can say, sir, how 0 factorial is equal to 1? Simple logic. Here in this one, you can replace n is equals to 1. If n is equal to 1, what you will get? Tell me 1 factorial. 1 factorial means, how you can write 1 factorial is equals to 1 into 1 minus 1 factorial means 1 factorial means 1 only into 0 factorial is the value. Therefore 0 factorial is taken as the 1. That's it. And this proof is not required for you. Just you have to remember 0 factorial is equals to 1. And n factorial equals to formula n into n minus 1 factorial. Now what is the 3 factorial value? Tell me. 3 factorial equals to 3 into 3 minus 1 factorial. Got it now? Means 3 into 2 factorial. Then again 3 into. Again 2 factorial. You can apply this formula. What you will get? 2 into 2 minus 1 factorial means 3 into 2 into. What about this value? 1 factorial. Then again 1 factorial value. 3 into 2 into 1 factorial value equals to 1 into 1 minus 1. 0 factorial is the value. But 0 factorial equal to 1 only. So you will get 3 into 2 into 1 is the value. So simply the product of the first n natural numbers is simply indicated by n factorial. So n factorial means 1 into 2 into 3 into 4 into up to so on n. This is one more notation, factorial notation. So basing on this one, what are the values? 0 factorial value we can take as 1. 1 factorial value 1. This is a factorial symbol. Otherwise some books they will go like this also. This is also 2 factorial. 2 factorial means 2. Next 3 factorial or 3 factorial is equal to 6 is the value. Next 4 factorial or 4 factorial is equal to 24 is the value. Next 5 factorial value is equal to 120 is the value. 6 factorial is equal to 720 is the value. 6 factorial means 1 into 2 into 3 into 4 into 5 into 6. That's it. So this is named as the factorial notation. Factorial notation. After this factorial notation, listen next. So I hope that this factorial notation you can understand. Now one more formula to identify the binomial coefficients, we will use NCR. NCR where N are integer values and R value always less than or equal to N. R value always less than or equal to N, and N value is greater than or equal to 1. N value greater than or equal to 1, and R value you may take greater than or equal to 0. These are the conditions. And NCR value is given by N factorial by N minus R factorial into R factorial. This is the formula for NCR. NCR. Okay, NCR means generally in permutations, combinations, we will use this notation. In detail regarding this NCR, in combinations we will discuss. Okay, so NCR formula is given by N factorial by N minus R factorial into R factorial. For example, 8C2. If somebody will give 8C2, then what is 8C2 value? 8 factorial by 8 minus 2 factorial into 2 factorial is the value. Then as usual, what is 8 factorial means? 8 factorial means 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 whole by 8 minus 2 means 6 factorial. 6 factorial means 1 into 2 into 3 into 4 into 5 into 6 is the value. 2 factorial means 2 into 1 is the value. So 6 factorial cancel. 2 4 times cancel, which is equal to 28 is the value, like this. So this is NCR formula. To calculate binomial coefficients, we will use NCR formula also. Now how you can find out binomial coefficients? With the help of this formula. For example, A plus B whole square is there. Then this value here square is there. So 2C0 into A square plus 2C1 into A power 1 into B power 1 plus 2C2 into B square. This is the notation. Okay. So 2C0. What is the value 2C0 means? Of course, here you can calculate. 2C0 is equal to, apply this formula, 2 factorial by 2 minus 0 factorial into 0 factorial. So numerator value 2 factorial by 2 minus 0 means 2, 2 factorial. 0 factorial means 1 is the value. Both get cancelled, 1. So here one important point, not only 2C0, even 3C0 value also 1, 4C0 value also 1. So that means NC0 always is equal to 1. This is one more important point. NC0 value always 1, where N is a natural number. N is a natural number. And R is a, here R is a whole number, you can take it. Okay, ma. Similarly, if you take the value a plus b whole cube, tell me in a plus b whole cube, starting with 3c naught into a highest power, ma. First term na a highest power you will get it. After this, what you will get? 3c 1 into a cube na. So here reduced by 1 and b will come. Next, guess it, what is the value? 3c2 into a into b square. What is the last value, ma'am? 3c3 into b cube is the value. Now if you calculate the value, which is equal to 3c naught, what is nc naught value? 1. So here you will get a cube plus 3c1. Calculate the value according to the formula, NCR formula. So 3c1 means 3 factorial by 3 minus 1 factorial into 1 factorial. 3 factorial means 1 into 2 into 3. 3 minus 1 means 2 factorial means 1 into 2. 1 factorial means 1 is the value. Both get cancelled, 3. So here you will get 3a square b. Even 3c2 value also you can calculate. 3 only you will get 3ab square plus b cube. Of course 3c3 value. What is the 3c3 value? Calculate here. 3c3 is equals to 3 factorial by 3 minus 3 factorial into 3 factorial. 0 factorial 1. 3 factorial cancel 1. So even here one more important point, ma'am. NCN, of course NC naught value 1. Just now we calculated. Even similarly, if you calculate NCN value also equals to 1 only. Keep in your mind this point also. NCN is equal to 1, NC not equal to 1, and NCR formula n factorial by n minus r factorial into r factorial, where n is the natural number greater than or equal to 1 and r is the whole number, and n r, the condition is given by r is always less than or equal to n is the value. Okay, these are the conditions. So with the help of this NCR, we can find the binomial coefficients. Got it, ma? I hope that this is clear. For example, if they will give a plus b whole power 4. For example, if they will give a plus b whole power 4, then calculate how you can identify a plus b whole power 4 value. Cross check one time. A plus b whole power 4 is equals to first value 4c naught into a power 4. Okay, means a highest power you will get. After that, a power decreased by 1, b power 0 in the first term, gradually b power increased by 1, and what are the coefficients, binomial coefficients of 4c naught? Next value 4c 1 into a cube b you will get. What is the next value, ma? Guess it. 4c 2 into a square into b square is the value. Guess what is the next term? Next term is 4c 3 into a into b cube is the value. What is the next term? 4c 4 into b power 4 is the value. Now if you calculate what is the value? 4c naught. 4c naught value 1. You will get a power 4. Then 4c1. 4c1 means 4 only you will get. A cube b plus 4c2. Calculate 4c2 value according to NCR formula. 4c2 is equals to 4 factorial by 4 minus 2 n minus r factorial into 2 factorial means 4 factorial means 1 2 3 4 by 4 minus 2. 2 factorial means 1 into 2. Again 2 factorial means 1 into 2. These two get cancelled. 2 times, which is equal to 6 is the value. So here what you will get, mom? Here 4c2 value as 6 into a square b square is the value. Same here also you will get the value. 4c3 value again 4 only, a b cube plus b power 4 like this. So with the help of this NCR formula, what is NCR formula? N factorial by n minus r factorial into r factorial. We can identify the binomial coefficients. Now basing on this, immediately your target is you can try for a plus b whole power 5 expansion. What is a plus b whole power 5 expansion? Do it. Now listen. For example, if I given a plus b whole power 5, of course, Pascal triangle method, one method. Without using that Pascal triangle method, directly with the formula. What is NCR formula? NCR is equals to n factorial by n minus r factorial into r factorial. With the help of this formula, we can identify coefficients. And here, what is NC naught value? 1, just now we given. And which is equals to NCN also. NC naught value, NCN value 1, you will get it. Otherwise, NCR equal to what is the formula? N factorial by n minus r factorial, r factorial. What is n value? N value greater than or equal to 1, that to integral value. R value greater than or equal to 0. And R value, N value. How they are related? R value is always less than or equal to N. These are the conditions for NCR formula. Now with the help of this NCR formula, we can identify the binomial coefficients. How you can identify? If you observe a plus b whole power 5. Expansion, do it, 5c naught a power 5. First a highest power you will get. After getting a highest power, gradually power of a reduced by 1, and here b power 0 initial term gradually increased by 1. So what is the value, next value? 5c 1 into a power 4 into b plus 5c 2 into a cube into b square plus 5c 3 into a square into b cube plus 5c 4 into a into b power 4 plus 5c 5 into b power 5, like this. So whatever the power is given, simply we have to find the binomial coefficients. These are the binomial coefficients. After writing binomial coefficients, a highest power you will get. From left to right, a power gradually decreased by 1, and b power 0 you will get initially. After that, b power value gradually increased by 1 and reaches the highest power. Now how to calculate these values? Already I given. With the help of the formula NCR equal to n factorial by n minus r factorial, r factorial. With the help of this formula, and NC naught equal to 1, NCN is equal to 1, where n value greater than or equal to 1, that to a natural number. R value greater than or equal to 0, that is also integral value. And R, n value related by r value less than or equal to n. Now if you calculate this value, you will get the value a power 5 plus 5 into a power 4 into b plus 5c2, you can calculate, you will get 10 is the value a cube b square plus 10 into a square b cube plus 5 into a into b power 4 plus b power 5 is the value. So this is the expansion for a plus b whole power 5. Similarly, you can try for a plus b whole power 6 and a plus b whole power 7 also you can try. Then what is a plus b whole power 6 expansion? Tell me. 6c naught into a power 6, a highest power. In the first term, you will get a highest power. Then what is the value next? 6c 1 into a power 5 into b. Gradually a power reduced by 1, b value gradually increases. Next value 6c2 a power 4 b square is the value plus 6c3 a cube b cube is the value plus 6c4 a square b power 4 is the value, 6c5 a b power 5 is the value plus 6c6 b power 6 is the value. And one more observation, How many terms are there here? 1, 2, 3, 4, 5, 6, 7. If the power 6 is given, so automatically the number of terms equal to 7. And how you can calculate the values? 6C0 value 1, 6C6 value also 1. Then 6C1. What is the 6C1 value? Cross check one time. 6C1 is equals to, according to this formula, 6 factorial by 6 minus 1 factorial into 1 factorial. Cross check 6 factorial means 1, 2, 3, 4, 5, 6 by 6 minus 1 means 5. 5 factorial means 1, 2, 3, 4, 5. 1 factorial means 1. Both get cancelled. 6 is the value. So 6C1 value 6. Even if you calculate 7C1 value 7. 8C1 value 8. By generalizing this, we can write NC1 value is equals to N is the value. NC1 is equals to N is the value. Got it, ma? So this is the method to identify the binomial expansions. And here one more important point. For example, a plus b whole power 6. How many terms are there? 7 terms are there. If you take a plus b whole power 7, then how many terms are there? 8 terms you will get. And this is the first term. If you observe a plus b whole power 6, this is the first term. And this is the second term. First term T1, second term T2, term 1, term 2. Next, third term. This is the term, third term. Next, this is the term, fourth term. This is the fifth term. This is the sixth term. And this is the seventh term. Now, by generalizing this value, listen here. N value 6 is there here. In the first term, 0 is there. In the second term, 1 is there. Third term, here 2 is there. Fourth term, 3 is there. That means, listen. Here, now I will explain about the general term in the expansion a plus b whole power n. Now, I will discuss about the general term in the expansion a plus b whole power n. So, in this a plus b whole power n, tr plus 1, this is important. The tr plus 1 is named as the general term. So, here t, how I can mention 0 plus 1? So, 0 is there. T2 value, T1 plus 1, 1 is there. T3 means 2 plus 1 or 1 plus 2. 2 plus 1 here. This is the value. T2 plus 1. So 2, here 2 you will get it. T4 means T3 plus 1. 3 is there. Here 3 you will get it. Like that. So general term in the expansion a plus b whole power n, Tr plus 1. That means R plus 1th term is called as the general term. And Tr plus 1 is given by NCR into A power R into B power N minus R. This is named as the general term. Okay, just you can compare here only. What is the T4 here? This is the T4 value. In the A plus B whole power 6 this is the T4 fourth term. Fourth term means T3 plus 1. So 6C3, A power value also 3, and here B power 6 minus 3, like that. So here you have to understand, in the expansion A plus B whole power n, in the expansion A plus B whole power n, the general term is called as Tr plus 1, and the general term Tr plus 1 is given by NCR into A power R into B power N minus R. I hope that this is clear for you. Okay. In the next class, we will continue few more details regarding this one. Okay. Thank you.